Again, different forms of atoms exist in nature. If an atom differs from the periodic table in the number of neutrons that it has, we call that type of particle an isotope, and we'll talk more about those in just a second. If it differs in the number of electrons, it will have a charge on it, a positive or negative symbol, and we call that kind of a particle an ion. And we'll come back to ions near the end of the chapter. Different isotopes of an element have different numbers of neutrons. Here we have some isotopes of hydrogen. Here's the most common form of hydrogen with its one little proton, its one electron, and no neutrons. Here's an isotope where hydrogen has a single neutron, and here's one where it actually has two. So these different forms of hydrogen can be found in nature, and we call them isotopes of one another. Another number that's used to represent isotopes is called the mass number. Now the mass number is a rough calculation. It represents the number of protons plus neutrons in the nucleus. So it's the number of things that are found in the nucleus. The mass number is represented as a superscript to the left of the atomic symbol. So for instance, this isotope of carbon is called carbon-14. Now what's the most common form of carbon? Well, carbon's atomic number is 6. So in carbon, the number of protons and neutrons are the same. So the most common form of carbon is carbon-12. Oh, if I can draw a 2. There we go, carbon-12. Another way to represent isotopes is to use something called the mass number. The mass number is the number of protons plus neutrons in the nucleus, so the number of things found in the nucleus. For instance, carbon has 6 protons and 6 neutrons, so its mass number would be carbon-12. That's the mass number for the most common form of carbon. Now here we have an isotope of carbon, carbon-14. What does that 14 indicate? Well, because the number of protons will never change, the presence of 2 extra things in the nucleus must be neutrons. So the presence of that 14 tells us that there are 2 extra neutrons in that nucleus. Because isotopes have different numbers of protons and neutrons, they tend to have unstable nuclei. And so those nuclei, like this one shown here, can fall apart slowly over time and release particles. When they release those particles, they release energy. And that energy is known as radiation. So isotopes are radioactive. The small ones, like carbon, only release a little bit of radiation, so we're well adapted to that. That's not dangerous. But some of the bigger isotopes, things like uranium and plutonium, those have really big nuclei, so they can release a lot of radiation, and they can be really dangerous. The rate at which an atom releases radiation is known as the half-life for that atom. Now, even though radioisotopes can be very dangerous, they can also be really, really useful in the lab. Because radioisotopes release energy, and because we can actually detect that energy, we can use radioisotopes to track things. So for instance, here an isotope has been released into this person's body, and it's been released in such a way that it will attach only to cancer cells. Then the body can be scanned for radiation, and you can see that there's radiation showing up here in the throat. So that's where the cancerous tumor is. It allows doctors to see where the tumor tissue is. Isotopes can also be used to determine the age of fossils. We can track individual molecules through a metabolic process. For instance, you can attach isotopes to glucose and see where the glucose travels inside the body. And as I said before, for diagnosing different medical disorders. So we use radiation quite a bit in science, and it's very useful. It just has to be used carefully in order to be used safely. Next, we need to discuss electrons. Now, electrons are the smallest particles, So why do we care about electrons? Well, it turns out that when two atoms get together and they want to make a bond to form a molecule, it's actually the electrons that are going to form that bond. So we need to understand a little bit more about electrons and how they behave.